Okay, we're going to be starting a new unit on radical functions. And the first radical function that we're going to look at, well, first of all, let's talk about what a radical is. A radical, you're familiar with this very common radical called the square root. Now, it's called a square root because whether you see it or not, there's a 2 in the little root here. This little v here is where you put the root. So if I wanted, this would be a square root. Okay, but if I wanted a third root, I would actually have to put a little 3 here for a third root. And if I wanted a fourth root, I'd have to put a little 4 in here. So, for example, the square root of 25, so what, two numbers that multiply times each other to get 25. So we know that would be plus or minus 5. Or we normally just go with the positive one unless we're solving. The cube root of 8, what number times itself 3 times gives us 8? Well, that would be 2, because 2 times 2 times 2 gives us 8. So the cube root of 8 would be 2, and so on. So anyway, that's what a radical is. There's quite a few different radicals. We're just all familiar with the square root. So let's take a look at the square root graph. Now, we've looked at it before, but we're going to revisit it. The square root function. Okay, and so this function is going to be y equals the square root of x. So we can simply, first of all, make a table if we were going to graph this. Pick some values. Now the values that I'm going to pick are going to be some perfect square values because the square root of 2 is like 1.141. I'm going to pick some nice perfect squares. Let's do some negatives. And some positive numbers. Okay, so if we do the square root, if I plug the negative 4 in, I'm going to get the square root of negative 4, which is going to be equal to 2i. Well, that's an imaginary number, okay? And we don't have imaginary numbers on our Cartesian coordinate plane. We only have x and y. So we can't graph that. Just like we can't graph the square root of negative 1, which we all know is I. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. We're just going to go ahead and graph the positive roots. So plotting them, we got 0, 0. We have 1, 1, 4, 2, and 9, 3. And there's our graph. So then our domain for this function is going to be from 0 to infinity. Or you could say, another way of writing this is x is greater than or equal to 0. That would work as well. The range, so the lowest point is 0, and it's going up infinitely. Or we could say y is greater than or equal to 0. That would work as well. Okay, so let's review the parameter changes. This would be the parent. Okay, so if we incorporate the parameter changes, we would have a, and then we have x minus h, and then we have k on the outside. So just remember that H is going to be your horizontal translation. And remember, it's going to be the opposite. And K is your vertical translation, up and down. And it is what it is, up or down. And then A is your stretch or compression, vertically. Okay? So for example, if we have y equals 1/2 x plus 6 minus 3, since this value is between 0 and 1, between 0 and 1, let's see, between 0 and 1, it's going to be a vertical compression. And here we have a horizontal translation of 6 units to the left. So 6 units left. And we have a vertical translation of 3 units down. So now if I was to graph this, okay, we would start at 0, 0 of the parent. We'd go 6 to the left. So 1, 2, 3, 4, 5, 6, and 3 down. 1, 2. We always do our translation first. Now, notice with the parent, our first point is 1 over, and our A value here is 1. So over 1, up 1. So here, it would be over 1, up 1/2. Half of 1. Okay? So the next one would be over 4. 1, 2, 3, 4. And then half of 2 is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Half of 3 is 1.5. So notice how our graph is compressed. Notice how our graph is compressed. Now the domain and range is also going to change. Notice the domain is not at 0 starting point anymore. Now it's at -6. So your domain is always going to be related to how this number affects x. So our domain for this function is now going to be -6 to infinity, because we put an arrow on the end. And then our range, notice it's been affected. The graph has been shifted not only 6 left, but also 2 down. So our range is going to be affected by our k value. So -3 to infinity. Or you could write these as x is greater than or equal to -6 and y is greater than or equal to -3. So on Monday we will be practicing graphing, writing the parameter changes down, and writing the domain and the range. And yeah, I think that's about it. The one thing that I left out here on the parameter changes is what happens if there was a negative. Okay, so remember that if there's a negative, we have a reflection across the x-axis. Okay, well, I'll see you guys on Monday. Don't forget to mark this video as done.